Okay, I'm just recording this in case I answer any questions that can help other people.
Okay. And I kind of think I might have a way to figure out the theoretical.
Okay.
So I was looking at the triangle and the tangent,
Yes.
and I kind of thought I could use the Pythagorean theorem
That's right. That's what you use.
to replace both h and r.
You want to replace h in terms of r and
L.
L.
Okay. And
So you're just using Pythagorean theorem. It's just, you know, the square root of r squared plus h squared equals L squared.
Yeah.
And then you're just basically solving for h in terms of r and L.
Okay. So
let me just let me see if I can do a quick screen share. Let's do a whiteboard share. Okay, can you see that?
Yes.
And so the let me see if I can import something. New share, probably not. Okay, so you've got basically my drawing here. So, you know, here's L. Come on, you. Here's H, the height, and then here's R. And then here's my theta that we're measuring it, right?
Yeah.
So, you know, tangent of theta is opposite over adjacent. So my tan theta is going to be R divided by H. And then you can replace H with some function of R and L just from Pythagorean theorem. You know that R squared plus H squared equals L squared.
Yes. So then we get H is equal to square root of L squared minus R squared.
Yep. That's exactly right. So then you're just going to replace tangent of theta by this function of R over H, which will be R over. So you're going to end up getting that tan theta is equal to R divided by the square root of L squared minus R squared.
Okay.
And then you're just going to end up replacing tan theta by that. So then ultimately what you're going to do is get the speed just in terms of R, L, and G.
Okay. Ooh, you were right. That's going to be something really nasty.
Yeah, I mean, it's not too bad, but I just wanted to let people know that it's going to be a square root inside a square root.
Okay.
I was go ahead.
Expecting it to be the whole thing under a square root, tangent, including the R, because I did see the video and it's just a square root inside a square root, but I didn't think it would be something over a square root.
Yeah, so.
Okay.
So then keep in mind, you're just basically getting one value of L, one value of R, and then one value of the period from the video.
Okay.
And then ultimately what you're doing is you are comparing the experimental. I mean, you know, they're both sort of experimental, but I was just calling the experimental one 2 pi R divided by the period. And then I'm sorry, I call that and then the theoretical one is the one that you get by basically doing Newton's laws. And this is where you're going to get a square root of some ugly function.
Yeah. Okay. All right, that makes more sense now.
Yeah. All right, I'm going to end this share. Stop share. Any other questions?
Other than that, no. I'm so far so good. I'm just gonna plug the data out of the video now.
Okay, I'm going to be in office hours until 1 o'clock. So if you have any more questions, come on back.
All right. Thank you.
All right, I'll see you later, Leo. Hey, Kendra.
Hi, Joe. Hello.
How you doing? Good, thanks.
Cool. Can I ask you a question about the homework?
Yes.
Okay, so for number 7,
So wait, what chapter are we talking about?
chapter 8.
So hold on, let me see if I can pull up something so I can see it. Physics 4A homework. Open
Yeah.
a new tab.
It should be, I have it right here. I don't know if you can see it, but it's the one with the car going up and down the hills.
Hold on, let me share this. Which number is it?
7. So
Problem.
yeah, it should be problem
Wait,
8.
chapter 8 or chapter 9?
8.
811?
It's problem 8.3.
Oh, 8.3.
Chapter 8 homework, but it's number 7 out of 10.
I'm having a brain fart. Chapter 8 homework.
Mhm.
Which problem number?
It's labeled as 8.3, but it's number 7 of the homework.
8.3. Wait, why am I? Where is? Do 8. Oh, it's late.
If you press the homework 8.
Oh, so okay. Let me log into Mastering Physics. Come on. All assignments. Chapter 8 homework. It's number 8.
Do you see that it's 8.3, but it's 7 out of 10.
Hold on, let me share this screen because I think I'm seeing something different. Course home. Okay, can you see the screen?
Yeah.
Which one is it?
It's number 7, 8.3. Yeah, that's the one.
Oh, 8:30.
8, yeah.
Oh, and if I click on it, you can't see the, let me see if I do this. Open in new tab. Ah, this one.
Mm-hmm.
Can you see it?
Yeah, I see it.
Okay.
It's part A of the problem where it's asking what the tangential acceleration is.
Yes.
How am I supposed to solve for that?
So tangential acceleration. So in this case, you've got, it is skidding. So the only horizontal force you have is the force of kinetic friction. So if I were to do, let's say, can I annotate this? Annotate. So if you were to do, if I draw a free body diagram of the forces acting on the car, what I basically have is the normal force, gravity, mg, and I've got the force of kinetic friction.
Would you put the F net going the other way as friction?
The net force, the F net in this case, would be acting to the left.
Because it's decelerating because it stopped.
Correct.
Okay.
So what is this? This is with hints, and they want to know basically what is the, I forget, what is the acceleration?
Yeah, the tangential acceleration of A.
So what I would say is the sum of the forces in the x direction equals max.
But the mass isn't given.
I know, but it's going to drop out, that you'll see.
Oh, okay.
So what you have, the only force is the force of kinetic friction. So I would get is the force of kinetic friction equals max. And my force of kinetic friction is mu k times the normal force equals max.
Oh, and then normal is equal to mg.
So the normal is equal to hold on one second. The normal is, can I move this at all? The normal force for this case is going to be mg, just because there's no acceleration up and down. But in these cases here, the car is moving in a circular path, and so the acceleration is not going to be 0. The acceleration is going to be v squared over r towards the center. Let me grab my book for a second. I feel like chapter 8. What is the tangential acceleration of each case? And let me stop this share for 1 second. I want to look at something real quick. Problem.
Okay.
Homework. No. 8. Homework. Yeah, so let me go back to this share again. Share screen again, and we were just doing online resources. What happened to that? Hold on. Why course home, mastering physics. Going back, cancel, share screen, share. Ah, deleted all that. So anyway, what you're going to get in for this case, let me annotate, draw. So actually, so let's look at this case here for the middle one, for B.
Okay.
So again, I've got my free body diagram is just the normal force, mg, and the force of kinetic friction. But here's a case where it's moving in circular path. The acceleration is always towards the center. So in this case, the acceleration in the y direction is going to be v squared divided by r. So if I were to do the sum of the forces in the y direction equals may, what I would get is the normal force minus mg equals mv squared over r. So my normal force is mg plus mv squared divided by r for case B.
Okay, and that'd be the tangential
So
acceleration.
this is just the north. So the only difference between these three cases is basically the normal force.
Yeah.
In case A, the normal force is just going to end up being equal to the weight mg. In case B, we've got the normal force ends up being mg plus mv squared over r. And then for case C, you're going to have to do the same thing. You're going to get a slightly different normal force.
Yeah.
And then in
Why
both,
is mg take away n equals ma for the last one?
so yeah, so then when you're getting the actual acceleration, you're saying the sum of the forces in the x direction equals max. The only force you have is the force of kinetic friction. So the force of kinetic friction would be mu k times the normal force, which equals max.
Okay.
And then I forget, let me just look one more thing. I want to see if the accelerate. Let me stop this share for one more second. Course home, homework. So yeah, so one other last thing is the acceleration in each case is going to be negative if I define to the right as positive. So let me go that one more time. If I'm doing this, darn it, course home, mastering physics. Stop, share screen again. So yeah, so if I define my axis, so that right here, annotate. So they're defining the axes as the x-axis is positive to the right. So when I do set up my sum of the forces in the x direction equals max, the force of kinetic friction is acting to the left. So it'd actually be negative the coefficient of kinetic friction times the normal force equals max. So then the only difference is you'll have a different normal force in all three cases. It's going to depend upon the mass, but then when you end up doing acceleration is negative mu k times the normal force divided by the mass. The normal force will always have a function of mass in it, and so the masses will divide out.
Okay. Okay. All right, cool. Thanks for helping me with that question there on that problem.
Yeah, you're welcome. Any other questions?
Yeah, while I have you here, can we go over real quick all the different ways to find velocity? Because I think I have it clear, but I just want to clarify really quick.
Okay.
Because I have right now that I have v can equal the square root of 2 times r. And I also have
Wait, v equals the square root of 2
r.
times.
Did I copy that down incorrectly?
Yeah, I don't know.
No.
So let me clear all this, clear all drawings. So you have v equals the square root of 2r?
Yes.
Yeah, I don't know where that came
Not
from.
familiar? Okay.
No,
Well,
I mean, that equation doesn't work because, you know, this right-hand side, I end up with units of the square root of m.
okay.
In meters, right? So v, you know, should have units of meters per second. So I can't have some function on this right-hand side that's just going to give me units of the square root of meters.
Yeah, I wonder what I thought of that one for. But
Yeah, so, you know, be careful about like just copying down equations from a homework problem or something like that, and then trying to use them for other problems.
Okay. There is also that v equals 2 pi r over the period.
Yeah, so this is if you know something is moving in a circular path of radius r at a constant speed. So that this just comes up, this is really just speed equals distance divided by time. So if something's moving in a circular path of radius r, the total distance it covers in one revolution is just the circumference, which is 2 pi r. And t is the period, and this is just the time for one revolution.
Yeah, seconds per revolution.
So this equation holds for uniform circular motion.
Okay.
So if you know something's moving in a circle of radius r at a constant speed, and you know what the period is, then you can just get the speed is 2 pi r divided by the period.
Okay,
But
cool.
keep in mind that's only for uniform circular motion.
Only for uniform circular motion.
Yes.
Uniform. Okay, and then also I have that e equals the square root of radius times gravity. Is that also for circular motion?
So this is specific, this is what's called the critical speed.
Oh, that's the critical speed, yeah.
And this is like the speed if something was doing a complete loop-to-loop. This is the minimum speed it would have to have at the highest point in order not to lose contact.
Okay.
So
and
this
then,
is very specific to finding the critical speed if something's moving in a circular path and it's going to stay in contact with the surface.
okay. And then finally, the W is also critical speed.
So omega is angular velocity. We haven't gotten to that yet. I'm not going to do that until
So it's
chapter
not going to
12.
be on the quiz?
It will not be on the quiz.
Okay, okay. So that is for that one problem though, where you have tension in two different places, which create an angle.
Oh yeah, so the solutions to that did have omega in it. So I'm not doing anything with angular velocity yet.
Okay.
So I think in the Which problem was that? Do you remember?
I think it was.
You know what? I think there was, I think in chapter 8, there was one homework problem that I assigned part of that I didn't put in the online stuff because it had angular velocity in it.
Okay. Okay.
So yeah,
I'll include it.
nothing with omega or anything like that. We'll get to that in chapter 12.
Okay, cool. Sweet. Yeah, I think I could have organized that a little bit better, but thanks for clarifying.
Oh no, totally, anytime.
Okay, cool. I'll get back to you if I have any more questions.
All right, I'll be here until 1 o'clock.
Okay, thank you.
You're welcome. I'll talk to you later.